In this lecture, what we're going to be doing is we're going to be taking a look at power cycles that involve vapor. And so we'll have a liquid, the working fluid of our power cycle will be going through a phase change. And one of the common fluids that we will find in these vapor power cycles is water. Water going through the phase change from liquid water into steam. So we'll be looking at vapor and combined power cycles in this chapter or in this lecture. So thus far what we've looked at in terms of power cycles, we looked at the gas power cycle and we considered a number of different ones there. We looked at the Otto, the Diesel, the Stirling, and the Brayton. So the thing that we found with the Otto, the Diesel, Stirling perhaps to a lesser extent, and the Brayton, these are gas power cycles that are quite often used in mobile applications, so be it an automobile, a ship, aircraft in the case of a Brayton cycle. We're now going to be looking at vapor power cycles. Now, the thing about vapor power cycles is they have traditionally or historically been used and developed in steam engines. And these were mobile applications. The first one was developed in 1770 by a military engineer for the French Army. And then that evolved into steam engines that were used throughout the early 1900s. In more recent years, this has evolved into power plants. So the systems that provide us with electricity, and these are stationary. However, there were also early steam engines that were stationary, as we'll see in the next video clip. So let's take a couple of minutes here and look at a few different applications of steam engines. So in that video clip, we saw a number of different applications of vapor power cycles, starting with a stationary steam engine that was used as part of a weaving mill back in the late 1800s. We then moved forward, well actually we moved back in time, but it was the first mobile application from the late 1700s, the French military engineer that I had referred to. That was the first mobile application of steam power, where they would build a fire underneath a boiler and it would generate steam, and that system might go for a kilometer or a mile on one single charge of steam. So it wasn't really that practical. And then we saw a steam engine that was used in the rail system. That was from about the 1940s era. And those steam engines were used throughout the world for many, many years, and some parts are still used. and you generate steam, and that is what gives you mobility. And then we concluded the segment with another train, and it indirectly is also powered by steam. However, the steam generation in the case of the Shinkansen in Japan would be generated either through a nuclear power plant or a coal burning power plant or a natural gas burning power plant that is stationary, and then you generate electricity, and that is what powers the Shinkansen. So those are some applications of steam power. And so what we're going to do in this lecture and the next few lectures, we're going to take a look at power plants. So more of the stationary application of steam, which is typically what we do today. So what we'll be doing is we'll be taking a look at steam power plants, the different designs or forms of steam power plants. There are many different iterations and variations that we will encounter. And then we'll look at ways of being able to analyze and determine the thermal efficiency of steam power plants. So that's where we're going with the next few lectures.